Field Engineer Guide to Working on the Building, Layout, Tolerances, and Install Support. In this video, I'm going to talk briefly about some of the other roles of a field engineer in this overall process and how valuable they can be from day one. So I'm going to head over here to my sketch pad, and I've got three specific things that I want to talk about. One of them is an example, and the other ones are general concepts. There are a lot of different things that a field engineer will do throughout the building to really maintain quality assurance, meaning quality from the beginning, and some quality control, some after the fact inspection. Although I do want to make sure that we're on point that safety and quality are what we do. They're not secondary things, and we have to reduce our dependence on inspection and focus more on how we can do things in a quality and safe manner right the first time. So there are a lot of things that field engineers do, and in the book Construction Surveying and Layout, there's some beautiful chapters at the last part of the book in version 3 that talk about different responsibilities, different control types, and different applications of field engineering. I'm going to use grid leveling as just one example. You can do this when you're talking about a building pad or if you're talking about a deck. Grid leveling is where you literally grid off. And you can do this with strings, you can do this with baby powder in a chalk box, you can do this with just little dots with your orange spray paint, your upside down spray paint. Once you have your grid, can set up your automatic level, sight to a benchmark, and pick up the actual benchmark plus your back sight equals your instrument height. Best practice is to hit over to another benchmark and pick up that benchmark and grab your backside and get your instrument height, and then compare your instrument heights. Then do side shots over here to the grids and basically come up with a heat map if you're looking at it on plan view, where you can have, let's say it's plus, plus, right on, minus, minus, maybe back into the plus, and you're literally doing a grid leveling heat map for what the elevation is through the deck or through the pad. And you might be like, Jason, this is an odd way to explain what you're about to explain, but I'm just using grid leveling as an example of 40 other things that field engineers do. I mean, we're talking quantities, we're talking horizontal, staking out horizontal curves, vertical curves, we're talking grid leveling, we're talking laying out profiles, we're talking about laying out spirals or architectural features that aren't, some kind of fixed line or square geometry. We're talking office duties. We're talking checking window openings with a jig. Like, a field engineer can do so many different things like this to make sure that we are, which was mentioned in a podcast with an awesome general superintendent from Ironmark, level, plumb, square throughout the entire structure, and that we have accuracy, which means we're in the right place, and precision, which means that from point to point we have accurate dimensions. Let me round this out. Primary controls around the job, secondary controls around the building, working controls around the component, and then from that working control or the grid, the lift drawing takes over and you can two-tape any component. So a field engineer literally takes, for every component, from the bases of bearings all the way to the component layout and with a drawing. That's beautiful. But there are a number of other activities that are mentioned in the book that field engineers do. And you're probably like, Jason, give me a comprehensive list. It's already in the Field Engineering Methods Manual, but here it is in one sentence. Anything that controls the quality of the building is the field engineer's duty. And so when you think about, like, are we doing self-perform or are we not doing self-perform? What are we going to use field engineers for? The answer is to make sure everything is right. Oh, here's a good analogy. I was worried about this video because it's very short, but this is getting really good. Have you ever played Minesweeper, where you literally click on the little squares and you're trying not to hit a mine? Or have you ever played a video game where something is like flashing red and it's about to explode? This is such a good video all of a sudden. Like, I just thought of this on the fly. Imagine your whole building and break the whole thing up into components. And if it's not checked by a field engineer, it starts flashing red and it's going to blow up one of these days. A field engineer's job is to double check every component so that they are not future landmines. So that's focus number one, and I think I pulled that off. I was nervous about that, but I think I pulled that off. Now let me talk to you just about a brief framework for how we go from structure to the interiors. When we're in concrete, the field engineer is laying out the baseline for the foundations. The field engineer is helping to control the elevations of the slab on grade. The field engineer is getting grid lines on that slab on grade so that we can go vertical with walls and columns. And it's very clear what a field engineer will do. When steel comes on the scene, they're just as involved. And I should actually say steel or masonry, because typically you'll have a combination of the two. When your steel structure goes up, those field engineers are very much involved in checking the edge plumb of the building, seeing how much the heat is affecting the overall horizontal dimensions, and helping to control the elevations as we go up, especially for slab on metal deck. So I'm going to call that horizontal plus vertical control through the structure. Then once we start to wrap that with an exterior and it gets more conditioned, it's more stable. Inside the building, let's say that this is the upper floor and this is the base floor. The field engineer will make sure that everything is going inside the wall properly for in-wall inspections, and that everything is going in properly for above ceiling inspections. And then that everything is being installed properly actually on those surfaces. So when you're going from concrete to the superstructure, steel and masonry, it could be concrete as well, to interiors, there's always something to check that is hidden. If you think about it, concrete and a wall are not much different. With concrete, it gets hard and gray, and with drywall, it gets soft and white. If it's dense glass, it's yellow, or if it's purple board, it's purple, but it's a different covering, but it's getting covered. So a field engineer, in addition to checking every component, is making sure that we are quality controlling anything that's being covered or hidden. And the last framework I want to leave you with for other responsibilities is that it doesn't matter what it is. You could take a crew, here's the foreman and the workers, and they're about to do a work inside of a zone, installing a work package inside of their tack time. And what do they need? They need two things. They need the information and they need the layout. So they're always doing survey and control, and they're always doing lift drawings, and they're always doing frontline inspections. And does this crew need to be safe, even if it's not a concrete crew? Absolutely. So field engineer's responsibility: lift drawings, layout and control, frontline quality, and frontline safety. And if that field engineer trains and has this framework, they will become some of the best project delivery leaders or superintendents this industry has ever seen. I'm going to turn this into a blog post. It'll become a chapter in our book. And I hope that you've enjoyed this and that we're expanding our mind here a little bit, because this is super important. On we go.